In this video, we will prove and use the derivatives of sine and cosine. To begin, the derivative of sine x is the limit as delta x approaches 0, and we'll use the limit definition of a derivative. Sine of, now the argument of sine is x plus delta x minus sine x over delta x. In this case, we have the sine of a sum of angles, and we actually have a formula for that. Sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So x will be treated as alpha and delta x will be treated as beta, and we'll go ahead and expand this in the numerator. This expansion is still subtracting sine x in the numerator and is all over delta x. At this point, you may be at a loss of what to do next. It doesn't seem like there's much commonalities, although we have a term with sine x in it, and we have a term with sine x over here. Maybe we could group and factor and perhaps get special trig forms. Let's try it out. Unfortunately, only two of our terms have a sine x. So I'm going to separate into two fractions. I'm going to have the limit of this over delta x minus the limit of the two terms with sine x over delta x. I know it feels like some of these moves are kind of arbitrary. And so you have to just imagine the mathematicians figuring these proofs out, just trying every possible way of rearranging it so that they could find something that they knew, some identity or something. So we've split up the fractions, and now let's remember our trig forms. The limit of sine over sine of an angle over that angle as x approaches 0 is equal to 1. So I see a sine delta x over a delta x. Cosine x does not have delta x as any part of its argument, so we're going to take the cosine x out of the limit. Cosine x times the limit as delta x approaches 0 of sine delta x over delta x plus, okay, we have the limit of this fraction over here. If we factor out a negative sine x, I believe what remains will look similar to this special trig form. So let's try that out. Negative sine x times 1 minus cosine delta x all over delta x. I'm going to take negative sine x out of the limit because it does not have delta x in its argument. So now we'll be subtracting sine x times the limit as delta x approaches 0 of 1 minus cosine delta x over delta x. All right, let's evaluate the limits. So we have cosine x times the limit of sine delta x over delta x as delta x approaches 0 is 1 minus sine x times the limit of 1 minus cosine delta x over delta x as delta x approaches 0, that is equal to 0. Wow, we have simplified it. Cosine x times 1 is cosine x. Negative sine x times 0 is 0. So what is the derivative with respect to x of sine x? It is simply cosine x. You ready to find the derivative of cosine x? Let's plug it into the limit definition. Recall that cosine of x plus delta x, the sum of two angles, can be expanded to be cosine alpha cosine beta minus sine alpha sine beta. So that's what we'll go ahead and expand the top two and see if we can get any special trig forms. Similarly, in this one we have some common terms. We have a cosine x in this term and a cosine x in this term. Let's try to group them, possibly factor. Okay, so now we've just grouped the terms with cosine x in them. So let's split the fraction to be this over delta x plus the limit of this over delta x. I'm putting plus because I haven't factored out the negative yet. Negative cosine x plus cosine x cosine delta x over delta x. Okay, I have something without delta x. I'm going to take it out of the limit, and then in this one I'm going to factor out a negative cosine x. Negative sine x times the limit as delta x approaches 0 of sine delta x over delta x plus the limit as delta x approaches 0. Factor negative cosine x out. We're left with 1 minus cosine delta x. Oh, this looks like a special trig form. Negative sine x times the limit as delta x approaches 0 of sine delta x over delta x. I'm going to take negative cosine x out of the limit. So this would be plus negative cosine x, so minus cosine x, times the limit as delta x approaches 0 of this special trig form. Alright, so we have negative sine x, the limit as delta x approaches 0 of sine delta x over delta x, that is 1, so times that by 1, minus cosine x times the limit of this is 0. So what is the derivative of cosine x? Negative sine x times 1 is negative sine x. Negative cosine x times 0 is 0. The derivative of cosine with respect to x is negative sine x. The derivative with respect to x of sine x divided by 2. I'm going to change the dividing by 2 to be multiplied by a constant, so I can use the constant multiple rule. So the derivative of sine x over 2 can be written as the derivative of 1/2 times sine x. And now I'm going to remove 1/2 from the derivative. 1/2 times the derivative with respect to x of sine x. We just learned that the derivative of sine x is cosine x. 1/2 times the derivative of sine x is cosine x. And that's our derivative, 1/2 cosine x. Also, you can write it cosine x over 2. That's the derivative of sine x over 2. The derivative of a difference. Okay, you have negative cosine x and then minus 3x. Difference of a function, the rule for difference of a function, states that you can take the derivative of each function separately and subtract. So we'll take the derivative with respect to x of negative cosine x, our first term, minus the derivative with respect to x of 3x. Each of these has a constant. Cosine x is being multiplied by -1. X is being multiplied by 3. So remove those constants from the derivative. -1 times the derivative of cosine x minus 3 times the derivative of x. -1 times the derivative of cosine x is negative sine x. Minus 3 times the derivative of x is 1. -1 times negative sine x is sine x. Minus 3 times 1. Sine x minus 3 is the derivative of negative cosine x minus 3x.